Good morning, everyone. Today we are here to learn more about the data engineering part, how we can clean data to build our ML algorithm. So, to start with, let me give you a brief introduction about machine learning. So, machine learning is a process in which we uh, not tell the computer to program something. We ask the computer to give us some insight about that data. The difference between a normal programming and a machine learning is that in a normal programming you give machine the data as well as the program and tell the machine to work something on that on your program and give you the output. In machine learning, what you do is you give the machine the data and you ask the machine to generate a program for that and then give you an output. So here explicitly, you don't have to provide any kind of code to the machine. You just need to give data to the machine. Machine learning is built on data. Machine learning, the core of machine learning is data. You need it good data to make your algorithm work better and better. So to start with machine learning, first we will focus on Pandas. Pandas is basically a library made by Python, which is used to play with data. I will show you some examples over here. So, what is data cleaning and why do we need it? Data cleaning is a process in which we clean the data. Let's suppose if we are working in any kind of environment and we need to build some algorithm. So, we will take data from the database. So, when we fetch data from the database, there are a lot of redundant data, nullable data, many kind of records are there which are not currently used right now. So we need to remove all those things to make our algorithm work more better. Let's assume that you are a student and I have given you a 10th page Excel and tell you to read that Excel and you need to give some take some and analyze those Excels and tell something important about those things. So if I give you an Excel which have a lot of redundant data of students, which have a lot of null values, the rows are not correctly there. So in you will face problem in reading those data to working with those algorithms. So same as machine. If we give machine a clear data, it will work nicely on the data. So let's focus on pandas. So this is the line which I use to import pandas. It is already a pre-built library in Python. You can install this thing using pip command. After installing, you will import it as pandas. Okay, let's import this. So now I am using Jupyter Notebook. Jupyter Notebook is kind of a IDE. You can use any kind of IDE. You can use VS Code also, but Jupyter Notebook is widely used by all the machine learning engineers, and most of the people who are using this kind of stuff use Jupyter Notebook because here you can see your input as well as your output in a notebook kind of thing. And you can add comments also. So when you later you want to come to your code, your code will be easily readable and understandable. So next we are creating a data frame. So here I am not using any external Excel file or any external CSV file to take the data from there and create a data frame object. Data frame is basically, it creates object of data so that you don't perform operation on a real data. Let's suppose if you are working in a company and the company gives you his data and asks you to analyze something from that data. So if you make changes in the company data, then it will be a kind of problem for you because you cannot change the actual data that is given to you. So that's why we use pandas. So what we will do, we will create an object of that data. Like in object-oriented programming, we know we create object from the class, and if we perform any operation in this object, it will not affect the baseline class. So here we will create an object of our data and we will do the manipulations over here and it will not affect our real world data. Later, when all the things are perfect and we think that this is a good product, we will uh, uh, import this as an Excel file and we will replace this data with this new data. Okay. So here I am not importing anything from outside, but that can also be done. We will be going through that thing in future courses. Okay. So here I am creating my own data. So I have used some of the columns like user ID. See, so here we can see I have created one user ID, and in user ID, I have given some user IDs. I have created a name, and here I have given some name. I have created last name, column name. Okay. And then I am printing my df users. Df users is this object which I am creating. Okay. So let's run this. So it's looks like this. So I'm printing it. Okay, let's not print it. Let's show it. Jupyter Notebook has one more benefit, that if you print directly the object, it will show in this form of tabular form. But if you want to see this kind of thing in VS Code, then you need to write a print statement, because in Python, we use print statement to print the columns. So this is the data frame which I have created. My data frame has one, two, three, four, five, six, seven columns and 11 rows. 10 and plus 0. 11 rows are there and 7 columns are there. My columns are user ID. The user ID is used. I have created a user ID which can identify. It is basically a kind of primary key. Like you have one primary key to directly collect means, which is unique throughout the table, which is used to take a means a unique thing, a unique feature. It is given to every like if you enroll as a student, your name can be same to different students, but your enrollment ID or your student ID is unique only for you. So user ID is kind of thing which is unique for every user. Then the name is there, last name is there, age of user is there, phone of user is there, email is there, and not useful column. I added this not useful columns because in real world data, there are a lot of columns which is of no use. Means uh, if I am, if suppose I am training one model, if I if I need weather detail to train that model, and my data sheet has weather detail as well as soil detail, let's suppose. So we don't need soil detail. So we will drop those columns. Those are not useful columns. So here I have taken one example of not useful column, and like this is my data. Let's perform some calculations on the data. Okay, so this is df user. This is my object name. Dot columns. Dot column is a function of data frame which will give me all the column names. So I have 7 column name: user ID, name, last name, age, phone, emails, not useful column. So it is useful when you have a large data set. Like suppose if you have thousands of columns or hundreds of columns. So by listing over here, it will give you an array of all the column names. So you can directly take that array and use it in further calculations, or you can analyze what all columns are there, what column. By seeing the column name, you can think that, okay, this column is needed by me, this column is not needed by me, some kind of that thing. Then we have a describe column. If we go for the describe thing, describe function is used only on integer column. So in this data, we have only 2 integer columns. First one was user ID, another one was age. So in user ID, we can see different parameters over there, like count. We have 11 records. So it has given us the count as 11. And the mean means the mean age is 31, means average age is 31. Then this is the standard deviation. How much from the mean the deviation is here. If the mean is 31, how much from 31, how much low is that? And how much above it is giving us the standard deviation. Minimum age was 19, maximum age was 50. It kind of describe the data to us. And if you are working with machine learning models, and if you want to create those things, you will get a lot of integer columns. So by using the describe, you can analyze the data. Okay, my age group is on an average 31-year age people use my this thing or this module, anything you can say. And the range is from 19 years to 50 years. You can analyze these things using the describe column. Then there is a function is null. Is null tell us that what all null things we have. Means if we run this, it tells us that how many null fields we have. Let's suppose here, if you can see in not useful column, we have all true, 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 but all where we have false, because if we see the data, here we have some unique identity thing, means we have something, while as in not useful column, we have none. So it is telling us how much data we have as none. So suppose in real world data, what happens when we create the data, like suppose if you are reading the data from microsensor, the microsensor stop working for, let's suppose, 2 minutes. So the data is not collected for that 2 minutes. So all that field will come as for time this much, none, for time this much, none, for time this much, none, because the data is not been collected at that time. So for that, we use this kind of thing to understand that, okay, I don't have data from this time period to this time period, and I have data for rest of the things. So this null function is used for that. And now what I will do is I will drop the not useful column. Actually, we can see that not useful column is not used. So you can remove any column using the drop function. You just need to mention the column name as well as axis equal to 1. Axis equal to 1 means we are talking about the y-axis. We are removing one column. So we are using axis equal to 1. If we are want to remove any row, then we will use axis equal to 0. If we want to remove any row. Okay. So we are removing one column over here. So we have removed it. So you can see that that column has been removed. But the catch is here. The column is not yet being removed from it. To remove that column, what this has given, we need to assign these things to the original data frame. So here, if I print this thing again, let's suppose I add one more row and I print this object, df underscore users. And I print it. See, not useful column is still here. Why not useful column is still here? Because we have dropped that not useful column, but we have not assigned that thing to our df.users. So what we need to do here, we need to write here df users equal to this whole thing. Then that will be removed permanently. So instead of that, it can be done in two ways. Either you can directly assign it over here, or you can add a property in-place equal to true. If we write in-place equal to true, what it does is the object which is calling him, it assigns the same values to that object. So if now we run it, see here, when we are dropping this with this special thing, in-place equal to true, now we don't have not useful column over here. So this is one thing. Then now I want to know, let's run this. Now I want to know that drop any. Now I will talk about drop any function. What drop any function do is, if we have a null column, if in any row, if there is a null value, it will assign that, it will remove that row. And we are using in-place equal to true. So it is removing that row and it is assigning the value also directly to df.user. Okay, df user. So we can see what it has done over here. 0, 1. Okay. Yeah. So we were not having such kind of null columns, so it has not removed anything over here. Okay, that's good. So now let's moving to drop duplicates. Now over here, we can see that there are some duplicates rows over here. Like, see, 237 and 237, John, Davis, 22, 22. The numbers is also same. The mail ID is also same. So these are redundant columns. The data has been captured 2 times in that row. So removing drop duplicates, what it will do, it will drop one of that row. If you are capturing the data 2 times, it will remove one row over here. So if we run this, what it will do, see, now see 237 was 2 times over here, but 237 is 1 time over here. But now as we can see, the indexing has not been changed that much. 0, 1, 2, 3, and then 4, 5 is not there, then 6 is there. So now we need to reset that indexing. Okay. So to reset the indexing, we use reset index command. And you can see every place I am using in place equal to true. because it is removing the duplicate and assigning the value to df user. If you are not using this in place equal to true inside the bracket of that function, if you are not giving that thing to the function, then what you need to do, you need to get that value and you need to manually put that value in df user. Okay, so both ways it can be done. After this, we will be resetting the index. So see, the index has been reset. Now, as we were not having 4, 5. Now the assignment of 4, 5 has been done. Okay, we just reset the index. That's it. We have not done much over here. Now, what we will do to clean the data more, we will we will see that in the name column, we don't have anything else other than A to Z or small a to Z. Like here in Alex, you can see a double underscore is there, a hyphen hyphen is there, sorry, hyphen hyphen is there. Any exclamation mark with the name. So we are using the property of regex in Python. So here what we are doing, we are using df user. Just see this part. Okay, just see this part. Then we will come to this part. We are taking the object df user. We are taking the column name. This column name we are taking. Okay, so we have taken this df user, means this whole data. Then we have taken this column name as name. Then we are using the string property. Okay, we are using string property as name was in string. As we have seen in describe, it was only describing user id and age, means user id and age are integers, rest all the things are string. I will show the info also of data at last. Okay, I will show you the info so that you can analyze how to check which is string, which is what do you call integer, that kind of thing. So we are using the string property. In string, we have a property replace. We are using that replace property. What replace property take is, it takes a regex. Okay, means you can replace many things, like replace property take what you need to replace and what you need to replace with what. So here we can say that I want to replace A with B. So everywhere A will be replaced by B. So here we are not using that. Here what we are doing, we are using this regex. Okay, that if this regex is there, then it is okay. Okay. Otherwise, if this regex is not there, then all other things we will replace with an empty string. Okay. So if capital A to Z or small a to Z is there in the name, then leave that. If any other thing is there, replace it with an empty string. So after doing this, and we are providing the regex thing also. Regex means regular expression. You can read up more about it using Geeks for Geeks, or if you will say that we can, then we can conduct a session on regex. It is a good thing to know. So that double underscore will be removed. That underscore will be removed after this. So now after this, we are printing df user also. And here what we have done is, here we are not using in place equal to true because replace don't have that property. So what we are doing, we are using these things and we are replacing all the things, and then we are assigning it to, means we have done the calculation. Like you write c is equal to a plus b. So a plus b is the calculation, then you assign that to c variable. So here we have done the calculation and then we are assigning that to df user name. And in data frame, this is the most beautiful thing. What the thing is, if you use a particular column name, then you can run all the things throughout the column. So it will run throughout this name column and it will remove any extra thing. So you can see the extra hyphen has been removed from Alex. The underscore is removed from Thomas. So these things have been done. Now we have written a function camel case. Okay, so you can see that this one is camel case, but see Johnson is not in camel case. Brown is not in camel case. We need the name in camel case. So we have written a function camel case. Okay. So here what we are doing is we are taking one text, means a string. We are converting the first letter of the string. As you know, the string is a kind of an array in which string is a character array of character. Okay, so here what you can do, we are changing the first letter of the text to capital and rest all the letters to lower. This is a kind of indexing thing. Here we give the start index, and after this double colon, we give the stop index. Start, stop. So see, if we have name like Arfa, four letter name ARFA, so we can use it like ARFA. So if we have written something, R means the string is stored in S. So if we have written S equal to S brackets double colons 2. So the length is 0, 1, 2. So it will print ARA. It will not print, sorry, ARF. It will not print A because we are using 0 to 2. It's kind of indexing. Start step, stop, stop, stop step. So we are taking from 1. So here it will take the 0th index. Let's suppose brown, and it will take B and capitalize that B, and it will store that in answer, and it will take rest ROWN, it will convert that into lowercase and it will return the answer. Now what we are doing, we are using the df, which is my data frame object. We are taking the last name column name and we are applying this camel case function over here. Camel case function over here. So what it is happening is we are applying each and every string over here. After writing this apply, each and every string in this column, use this camel case function and change itself. And now after doing the calculation, we are assigning it back to the last name. So now if we will print this thing, oh, we have not run this camel case, that's why it's giving error. Okay. So if you print this thing, see, brown was with small b, ROWN. Now brown B is capital. So we have successfully created one method and we have successfully implemented that method. Now we are using formatting. Okay. Now we are using formatting. See, the numbers are there and the numbers are currently in string format. You can check it using info method. Let me show you. I told you that I will show you that thing. Okay, df users users dot info. Okay, so if you do that info method, you can see that this is the column name. This is the non-null values. There are 8 non-null values and its data type is integer. And name is object, last name is object, age is integer, phone is object, email is object. Object means string, means it is a kind of object type. So you can consider it that it is stored in form of string. So here you can see that phone is stored in form of object, means string. So here what we can do, we are using formatting. Here, see, we can see that the string is in this form. It is separated by slash. Maybe when the string, that number is being stored in the database, some slash formatting was used. So it has taken that slash formatting. Not, we don't want that. We need a good formatting for that. So now what we will do is we will create this method formatting. Here what this formatting method is doing, it is creating in one actual string, an empty string actual. It is iterating through each and every what do you call, each and every character of that string number. Like if the number is, suppose this, we can see this. If the number is 777889999 kind of stuff, it is iterating through it. And see, different formats have been performed. Here it is slash, here it is underscore. Means every person who has entered the data has entered the data in different formats. We need a single format for everything so that the data looks clean and good. So now we are using formatting. What we are doing, we are iterating through each and every character of that number. And we are checking that if character is digit is a function in Python which checks that if the number is a digit or not. Okay, so is digit is a function which will automatically check that it is a number or not. Okay, so it is checking that it is a digit or not. If it is a digit, then it is adding that into actual. So if you print actual over here, what it will print? It will print 7778888 and 4 times 9s. It will not take any hyphen, any slash, any brackets. It will not take all those things. It will just take the numbers. So now you have removed all those special characters from that number and you have stored that number. Now, to give a clear understanding about the number, okay, what we will do, we will use a case. We will use that indexing again, which I told you previously. 0 to 3 means from that numbers are of 10 digit. From 0 to 3 means 0, 1, 2. Start, stop. 0, 1, 2. First 3 digit it will take of actual. And after that, it will add a dash. Then it will take 3 to 6 means again 3 number it will take. It will again put a dash. And then 6 and then onwards means after that it will take again 4 numbers. Okay. And it will return that. Now what we are doing, we are using it into the phone. We are using the DF user class. In that we are taking our column name as phone. We are applying our formatting function to it. This formatting function is formatting all the things and creating it into a single thing, means all the number will have that dash dash symbol, and it will all be identical. It will not be like this curly braces or slash underscore. It will not be like this. Everything will be like this. Okay, with that dash dash. So let's see. Let's run this function. And then after doing this, we are assigning the value to phone. Okay. So see, now every phone number looks pretty much the same. First 3 digit, then again 3 digit, then rest of the digit, these kind of things. Now this formatting has been done. Now what we are doing, we are checking the unique element of user ID. As you know that user ID is a unique field. Every one should have different unique ID. So if I run this, it will give me number of unique element in that. So number of unique element was 8. So by this we can understand that there are 8 unique users which I have. Means I have data of 8 unique users. You can check what all unique users you have. Like suppose if you want to check it here, you can create one. Wait, let me create one thing. Is it? Okay. Let me create one more column. Here what we can do, instead of doing this, we can do this. We can use unique method. Instead of n unique, so it will give you array of all the unique element which is present over there. Array of all the unique element which is present over there. Okay. You can use, if you want the name of every person, name of all unique person, instead of user ID, you just change the column name, run it. You will get all the unique name of every person, unique name. So this is my cleaned data. Now this is my data which is fully cleaned, and now I can use it for my machine learning tasks. Okay, so now that data is cleaned. Now I will take this data and put it into machine, and we will create different algorithms using that. So we will create a lot of algorithms. Some are for classification, some are for regression. We will have theory sessions as well as practical sessions so that you can understand it in more good way. So thank you. This is your instructor, Zeeshan. Thank you.